In the previous video, we learned how to make our NavMesh change at runtime. In this video, we'll learn how to use links to connect together multiple NavMesh surfaces. We'll also finish things off by implementing an animated character to replace our cylinder. Also, this video is sponsored by Unity. So let's jump right into it. So as you can see here, I have a simple scene with two ground elements. Both of these are just simple cubes, and I've gone ahead and named one ground 1 and the other one ground 2. And if I go to my NavMesh here, I can hit bake, and you can see that both surfaces are walkable to our agent, but there's of course a gap between them. So if we were to select our player now, we can see that we have the NavMesh agent, and I've gone ahead and added the player controller that we created in the last video. And if we play, we can move around one of the ground planes, but there's no way for us to go to the other one. To change this, we can use a NavMesh link to connect them together. We'll go to our hierarchy, right click and hit create empty. We'll reset the transform and let's rename it to link. Let's also add a new component, and we want to add a NavMesh link. And if we now zoom in, we can see this illustration of two arrows connecting two points. We can of course control where we want these points to be. I'm just going to take the entire object and hold down Control while rotating to make it span from one surface to the other. I'm also going to go ahead and move it up so that these rings here are placed right on top of the surface. And this is pretty crazy, but that's pretty much all we need to do. If we now go into our game and hit play, we can now click on the opposing surface, and our NavMesh will use this link to transition from one to the other. You will notice that if we click over here, our agent has to go through the link in order to reach that position. If you look closely, you can see that the agent speeds up when using the link. This is the agent exhibiting jump-like behavior. When creating a NavMesh link, we aren't creating a surface. Instead, think of it more like a teleporter, where when we meet the start of the link, it will simply quickly move the agent to the other side of the link. There are also some different properties that we can modify on our NavMesh link. Most importantly, we have the width. This allows us to make our link wider so that our player can use it over a greater area. If, for example, we wanted to make pretty much this entire gap into a link, we would just increase the width in order to do that. And if I now hit play and tell our player to move, you can see that he just uses the shortest path there. We can also choose whether or not we want the link to be bi-directional. If we disable this, our player will only be able to use the link one way. In our case, we'll be able to walk across here, but we won't be able to transition back. And then, as with the other NavMesh components, we can also choose an area type for this link. But right now we're just using our link to connect between two parts of the same NavMesh. We can actually use links to connect between multiple NavMesh surfaces. An instance of where this is particularly useful is if you're loading in your level in chunks and you want each part of your level to have a separate NavMesh. Well, then every time you load in a new part of your level, you can simply connect it together with the old one using links, and everything should work just fine. So if we go ahead and select our NavMesh here, we can actually duplicate it. I'm going to name the first one NavMesh 1, and the second one I'm going to drag to the top and name NavMesh 2. I'm then going to select my first ground here and add it to a layer. This one is going to be ground 1, and I'm also going to add another layer which is ground 2. Then if we go to our ground 1, we need to assign ground 1 here. And for ground 2, we'll assign ground 2. If we then select our first NavMesh, we can make sure to not include ground 2 and we'll hit bake. So now this only includes the first ground. And for our second NavMesh, we can make sure to not include ground 1 and hit bake on this as well. And now this only includes our second ground. So if I disable one of these, we can see that they are now on two different NavMesh surfaces. And if we hit play, you'll see that our link still works just fine between them. So that just opens up a whole nother world of possibilities. And now that we have a great amount of control over our NavMesh, it's time to replace this boring looking character with a cool animated one. To do that, I'm going to open up example 5 here. In here, I just have a simple level. I'm going to select my NavMesh and hit bake. And on this level, I have the player character with pretty much all the same settings as before, as well as the player controller. And we of course want to get rid of this boring cylinder. To do that, we'll go to the top here and we'll right click and remove the mesh renderer. We'll also remove the capsule collider as well as the mesh filter. So now our player is pretty much invisible. Instead, we want to add in a character called Loman. As always, if you want to get these example scenes as well as the character that we're going to be using, visit the link in the description. So if we go under example 5 Loman, there's a folder here called Loman. In here we have some different folders for our character. We're going to go under models and we're going to select the low body. Now if we select it, we can see our simple low poly character. To add this to our player, we'll simply drag it under our player objects. And right away we're going to see it in our scene. We won't be applying any animation just yet, so I'm going to right click on the animator and remove it. And now if we go into our scene view and hit F to focus on him, we can make sure to position our player correctly. I'm just going to reset the transform so that he's completely centered on our object. I'm then going to go under our player and I'm going to go to our NavMesh agent and remove the base offset. So I'm going to set that to 0 and that should snap our collider right in place. And then we can go ahead and place him on the ground here. Also want to make our graphics a tiny bit bigger, so I'm going to select low body, change to the scaling tool by hitting R, and just scale him up a tad. I'm also going to go under the materials and assign the low body material to him. So now if we go and hit play, we will be able to move him around our scene, just as before. But of course, it's very boring when he doesn't have any animation applied. So how do we go about this? Well, so far we've been using some simple graphics to illustrate our player. And whenever we've moved the player in a given direction, we haven't been changing those graphics at all. And that's just fine when using a simple shape. But now that we're using a character, we want him to animate as he moves forward. And more importantly, we want this animation to line up with the way that he's moving. In order for this sort of animation to look natural, we want it to look like the character's feet are the one that is driving forward the motion. In other words, we have to always make sure to sync up our animation with the actual movement. In most cases, there are two ways to go about this. The first one is moving the character using the NavMesh agent. This is not far from what we've been doing so far. We have our NavMesh agent, it wants to go in a certain direction, and so it goes ahead and moves in that direction. Then for any given point, we could simply overlay some animation on top of this movement and then do our best to try and synchronize the animation to the movement. The way that we'd probably do this is by asking for each point what the current speed of the agent is, and then adjusting the animation speed and what animation to play depending on if the character is moving quickly, in which case we want to run, if he's moving slowly, in which case we want to walk, and if he's not moving at all, in which case we just want to go and play some kind of idle animation. And this is fine for very simple animation, but things quickly become more complex, because our character is not only moving forward, he's also turning to the sides. And this should be shown in the animation. And it also requires a lot of work to try and synchronize the two perfectly. The second way to go about it is using animation to move forward our character. Here we have the agent running in the background. So for any given point, we are still running the NavMesh agent. But instead of just having it move forward our character, for each point we're asking, where should we go? And we then play an animation that moves us in that direction. And so here the animation itself is what drives the player forward. Now this method also requires some tweaking and quite a bit of code, but luckily Unity recognizes this and have created a script that does exactly this. The script I'm talking about is the third-person character script. It's part of the standard assets and I've also included it in the example scene. If we go ahead and add this to our player, it's going to add a bunch of different components. But most of these we can pretty much leave as is. As for the third-person character script itself, I found that the default values work just fine. So I'm just going to collapse that. The same thing goes for the rigid body. And as for the capsule collider, we just need to make sure to fit this to a character. I'm going to increase the height to 2 and move it up by 1. And that's all we need to do here. Now we can go to our NavMesh agent and change the speed to 1. And we can pretty much leave all the other settings. One thing that we do have to set up is our animator. And this is because we need to specify what animation we want to use, as well as how this animation should be applied to the bones. First of all, we need to apply an animator controller. If we go under Loman animation, we can see the humanoid controller right here. We'll go and drag that in. And as for the avatar, we want to be using the Loman avatar. So we'll go under low body, select the low body avatar and drag that in as well. And now a player is actually set up to use animation. If we select him and open up our animated window, we can see how all the different animations correspond to each other. We have a bunch of different animations in here, like a death animation, a win animation, an animation when airborne and when crouching. And under the locomotion, we have a bunch of different animations for movement. In the left-hand corner, we have some different parameters. And the cool thing is that our third-person character script will go ahead and adjust all of these animations accordingly, depending on the situation. So pretty much all we need to do is start using our third-person character script. To do that, we'll open up our player controller, and here we want to add a tiny bit of code. The first thing that we want is a reference to a third-person character. And whenever we're using something from the standard assets, we need to go to the top and say using Unity standard assets. And in our case, we want to go under characters and use the third-person character. So now we can create a new variable, a public third-person character, and we'll just call it character. Then we also want to create a start method, so we'll go void start. And in here, we simply want to tell our agent not to update its rotation. This is because our rotation is handled by the character. So we'll go agent.update rotation equals false. And now we're pretty much set up. Now we simply need to move our character through the third-person character script. To do this, we'll go to the bottom of our update method. And to move our character, we'll use character.move. And this takes in a vector3 that defines where we want to move and whether or not we want to crouch or jump. And as we talked about, where we want to move is determined by our agent. And here we can use a super handy parameter under our agent called desired velocity. As the name suggests, desired velocity is where our agent would like to move at this given point. So we'll input agent.desired velocity. And then we'll write false because we don't want to crouch, and false because we don't want to jump. Now, of course, there's no reason for us to move if we've already reached the end of our path. So we're going to put an if statement here saying if agent.remaining distance. And as we can see here, remaining distance is the distance between the agent's position and the destination on the current path. So in the case that our remaining distance is greater than agent.stopping distance, and we set this to 0.2 inside of the inspector, well then we still want to move. So in that case, we still want to call character.move. And if not, meaning that our agent has reached its final destination along the path, well then we want to stop our character from moving. And this is maybe a tiny bit counterintuitive, but in order to stop our character, we actually do have to call move. But instead of giving it an actual movement, we simply feed it vector3.0. And so we say stop moving. And again, we want to input false and false. And that's pretty much all we need to do. In the case that we still want to move and haven't reached our destination, we'll go ahead and move according to the desired velocity of our agent. And if we then reach our destination, we'll go ahead and stop moving. It's actually that simple. If we then save and go into Unity, we now have an empty field for a third-person character. We'll go ahead and drag that right in. And now when we hit play, we should see that right away our character transitions to an idle animation. And if we start moving, our character will realistically animate to the desired position. Notice how when the character is not moving very quickly, he's only using a walk animation. If he's moving more quickly, he transitions to a run. And whenever he's running around corners, he will go ahead and tilt his body to show this. We can also take our animator and move it to the right here. And this will actually allow us to see what animations are currently playing. So we can see how we're transitioning our turn and forward motion in order to play the correct animation. So from here, it's just up to you to have fun and get creative. That's pretty much it for this video and this NavMesh series. If you want to learn more about NavMesh or if you have any questions, I suggest you check out the documentation. There will of course be a link for that in the description. Now we have plenty of more Unity videos coming, so make sure to subscribe to get notified once they're out. Other than that, thanks for watching and I will see you in the next video. Beep, beep, beep. Thanks to all of the awesome Patreon supporters who donated in February, and a special thanks to In Code We Trust, Patrick McGinley, Diego Geik, Frank, Tristan Down, Dying Guyan, Beffy O, Infinity PBR, Yorai Omer, Hans Hoftoon, Cyborg Mummy, Derek Heemskirk, Faisal Marify, Beardo Die, Double Tap 45, James P, J Delay, Superman the Great, John Beauregard, Dennis Sullivan, Jason Latito, Alex Rikitsky, Björn Fudoknap, Svetlin Svilenov, Jin, Sasha Hopstein, Sune Jacobsen, Gregory Pierce, James Rogers, Robert Bund, Judaman, Rob Fern, and Erasmus. Whew. You guys rock.